What this video is about is a refurbishment of a solid-state ignition, SSI. This ignition happens to be off of an ESKA outboard motor, a single cylinder, 7.5 horsepower. This is a 610 851. The ignition on the tractor engines, the HH100s and HH120s, are almost identical. But those ignitions have two triggers. This one only has one trigger here. The tractor ignitions have one trigger here and another trigger here. The primary difference is that the outboard motor that this is off of has a mechanical spark advance, where the Tecumseh tractor engine is a fixed spark advance above a threshold. So what we're going to do is make some cuts across the epoxy and then pop it off in little sections. This way we can avoid using a torch. The first thing we need to do that is to grind off the edges here and here and here. This will, when we grind off this edge, it'll basically disconnect the cover for the printed circuit board here from the sides, which is what is largely what holds it on. So in order to do that, I'm going to start out with a bench grinder, removing as much as I can, and then I'll finish up with a Dremel tool. Okay, you can see what I did is I took about a 45-degree angle off the sides, and you can see the white edge of the printed circuit board here. So we need to do this step first so that on the next step we can know where that printed circuit board is. You can see the white line here, the printed circuit board over on this side. So I pretty well have this epoxy area disconnected from the printed circuit board. I didn't mention earlier, but I made a little tick mark here about 1/4 of an inch from the trigger. I marked the trigger here, came over 1/4 of an inch because we need to stay away from the trigger. We don't want to go near that. But over on this side, there's a connection down in here where the trigger coil connects up to the SCR, and we need to get to that. So I came back 1/4 of an inch from this corner to here, and I made this line and I brought it. So what we're going to do next is I'm going to take a hacksaw and cut across this line here, and then when I'm finished with that, I'm going to cut across this line here. Don't need to go completely down to the printed circuit board. If I can begin to see some solder joints or something, I want to stop. But now that we cut this edge off, we can see where the printed circuit board lies. Now what we did is we have those two cuts. What I'm going to do, and I haven't done this before, so I hope it works, is I'm going to put a small screwdriver down in this cut here, and I'm going to pry this little piece off, prying against what's left here. So let's just put that in there like that a little bit and pry it, and bingo, off comes the little piece of epoxy. So we got strip 1 done, and now we can go to strip 2. Okay. There goes strip 2. Now you may be tempted to cut all of these at once, but if we do that, we may break it off where we're prying and not the piece that we want to remove. So I'm going to go ahead and cut these one at a time until we get this down to the printed circuit board. Okay, got that cut done, so let's see how this one goes. Oh my gosh, that cam's coming off so easy. Why didn't I do this about 10 years ago when I started fixing these things? Oh. Okay, moving right along. Boy, this is better than sliced SSI. This is working great. Wow, look at that, would you? Man, I thought I saw this board moving a little bit here from the vibration of the saw. So maybe I just cheat here a little bit. Look at that, would you? Woo-wee. Okay, that worked great. I'm going to be trashing all the rest of that stuff on using a torch to clean those off. Okay, now we got this cover off. Easier and better than ever. The capacitor is, one end of the wire is right here, and I really don't want to mess with all of that. And the other end is over here, so this is an area that's pretty easy to get to. So I'm going to take the solder off of this one, make it a little easier. Okay, it's a little awkward for me working around this camera and the light I have here, but now we'll disconnect the capacitor. Okay, that's good. Okay, now with that all done, you'll see later that we're going to mount a capacitor right across the top of this printed circuit board directly. And I want it to, if there's any wires sticking up with a little sharp edge, I really want to knock them down. So I'm going to do that right now. What we have here is a solid state ignition from a Tecumseh engine on a Sears tractor. The part number for the Sears version is a 610-759. At this point, we're just going to mount this thing in here. We've got all of this stuff here for a connection, and the other end has to go right in here somewhere. So I'm going to bend the wire leads to accomplish that. Okay, the capacitor we're using is one that is specifically designed for charging and discharging repeatedly. And that involves a lot of currents in the capacitors, and they're not all made the same. So I would strongly encourage you to use this type of capacitor at least if you're going to do the replacement. The other thing about this capacitor is it has a very low profile to it, so we can mount that directly on the printed circuit board and not have to be concerned about hitting the flywheel. There's plenty of clearance in there, and if you wanted to check it, you could take some of your grandkids' Play-Doh and put a dab on there and check it. But the capacitor is I obtained it from Mauser. It's made by Cornell Doubler, Cornell Doubler part number. It's a thin film capacitor, much better than the technology that was in the old capacitors. It's rated at 400 volts, and it cost a little over $2. And you can get the data sheet on this Mauser part website there. So this is the capacitor that we need to mount on the board. Okay, at this point I have soldered one lead of the new capacitor right here, and then after doing that, this one was easy, soldered the second lead over here. So that gives the ignition a new capacitor. Normally the next thing to do would be to seal it all up, and I use E6000 industrial adhesive. For that, I can either get hardware stores or Lowe's or hobby stores. So before I do that though, I'm going to run this ignition again on the engine simulator and see how well it works. Okay, I ran the unit on the engine simulator and I got a very loud, snappy blue spark. So the ignition is just working just fine. There was no intermittency to it at all. I should point out to you that this is a capacitance discharge ignition system. What we have here is a charge coil. When the magnets fly by that, it goes off and goes through a diode. It charges this capacitor up. It's a 1 microfarad, which is a pretty sizable capacitor, and it charges it up somewhere up near 400 volts. So there's a lot of energy stored in that capacitor. Now when the flywheel goes by the trigger, at some RPM here, the advanced trigger, it will trigger an electronic switch which will basically short all that energy in a capacitor right across the primary winding on the transformer. The output is many times more, and so you might get 26,000 volts out of there. One thing to remember, the capacitance discharge ignition system is, the spark is very different from a magneto spark or from an automotive type make-break spark. This spark is blue. I could hear the spark before I could see it, because I suspect that some of the energy is in an ultraviolet spectrum where I couldn't see it, but some of it was blue. In a magneto type ignition, you're used to seeing a white spark, and a spark that might oscillate and hang around for a while. This one is not that way. When this capacitor gets shorted against the primary winding of the transformer, it discharges within a millionth of a second. Bam! And that's the end of the spark. So it's all finished at that point. So anyway, the CDI spark is quite a bit different than the white spark. After I tested successfully, I potted underneath the capacitor initially first with some E6000, and then this had a chance to set up, so I sealed this all up again, and so protected from the weather. So at this point it's ready to be installed and go. Oh, one thing I should point out, this connector here is called a flag connector. The special connector in here, and it's all tucked in here so it doesn't touch the flywheel. The wire from this thing has to go down here like I've shown it, and it goes out behind the flywheel where so the flywheel cannot rub on it. So the way you wire this thing is there's only one right way to do it, or you're going to have maybe a spark for a little while till the wire rubs through, and then you're going to have a failed ignition again. So notice how the routing of this wire is. So that's the end of this clip. Thank you.